This conference will now be recorded.
So good morning, afternoon, and evening. Hopefully not night. I don't think so. Everyone, all across the globe again, which is good to see. Thank you all for joining again. We've got an agenda for today, and as usual, we're going to start with establishing the agenda. Is there anyone who would like to cover something specific for today? Does anyone have a contribution or something else to cover except for besides the normal points?
None for me, Rolf. Thanks.
Right, cool. Okay, so there's quite a bit of inputs to the immersion requirements. I've done some major updates as well, so I've consolidated a lot of the feedback. I see that Nigel's made a lot of points that we're going to need to go through, so I'm afraid that's going to take a lot of our time today. This is essential because the day after tomorrow it will finally be going through the incubation committee. Well, I would say again because that was scheduled to happen 1.5 months ago. Didn't, but we had the problem at the time that we didn't get all the licensing information in place in time. So therefore the submission has been delayed until the day after tomorrow. So we decided to include some of the suggested changes over the past 1.5 months in the document, and this document will be finalized today for submission the day after tomorrow. So anything that we cannot go through today, we will have to delay that content until the next revision, which we're going to start working on after this Thursday. But the document that will be going through the incubation committee will be the final document. So that is the major part of the work effort for today. I will do a short debrief on the IT gear specs session from last week. And if there is no additional presentations or inputs that anyone wants to cover, I think that's pretty much the outline of the meeting today. Does anyone have anything to add or to say?
I think from my side, Rolf, when I went through the document, the current document that was confirmed yesterday, I found some inconsistencies within the document relating to how the ash rate terminology was interpreted. So the number of changes are to try and correct that those statements, just to try and ensure that we put out a document that doesn't conflict with any of AshRay's perspectives and doesn't embarrass us to some extent.
I fully agree, especially on the embarrassment side.
Exactly.
So yeah, no. So let's make sure.
Sorry for the detailed changes, but I think we need to do it.
No, that's good. That's all good. If we can agree at least on the content of the changes, will you perhaps have some time to? Because I think we may not be able to get through them all during this call. Will you have some time later on tonight to run through these changes together with me for finalizing the document? All right, then at least we can stick to go no goes in this call, and we'll work out the consistencies offline.
Perfect.
Yeah. All right. Great. So I will start with the suggested changes. Sorry, correction. I will start with the actual documents with the content that I've processed by now. The last major change was from this afternoon. I actually found a little bit of time to wrap something up. And I'm just gonna take you guys through what has been changed. So the first major thing that has been changed, and this one is actually from today, is a glossary. There's been numerous discussions in which a glossary was mentioned to be critical for this document. So I decided to make an inventory of all the words and abbreviations that are related to immersion specifically that people may not be used to.
Capital
I
F,
formulated, yeah. Right, and I try to come up with an explanation for most of these. So a lot of this stuff has been simply copy pasted from Wikipedia or a dictionary. If there's anything that instead of going through every single item here, I would like to request everyone to walk through this glossary. If there's anything that you don't agree with, let me know directly, and I will be able to edit this. If possible, if you feel that there are too many discrepancies, or we might end up being embarrassed by some of the explanations in here, then I can always take the whole thing out again and keep that for a revision 2 of the document.
Rolf, stot. Do we need stot in it? It seems to be
it's used. Yes, it is used in the document when it comes to the liquid specifications. Right over here.
Perfect. Okay, good.
Yeah, so this is a list of the required liquid specifications that must be made available if somebody requests it, or that must be.
Okay.
Yeah. So it's there's nothing in here that is not used in the document. So I've actually used the text of the document to identify which. So I've also included bus bar and redfish in here, which I think is a bit over the top, but hey, things like heat exchanging device. But if there's anything that might not be consistent, or that you feel that might not be accurate, or a misrepresentation of what it should be, let me know. I've added a line that's the definitions are provided within the context of immersion technology within data centers. So that means that the official scientific explanation of something may be too generic to be used here. So
I think we separate data and centers in our through the document. I don't know if it's used. Yeah, it's separated.
Okay.
You've just
I'll make
separated
a note of that. I will use that. I will do that in the final edit to make sure that that's all consistent. I've just made a note of that one. So no need to remind us to that one from now on. Are you all going to be able to go through this glossary within the next within the next 24 hours or so?
Yes, I will.
Yeah.
Yep.
I would appreciate that. Thanks. And any feedback, if you can consolidate it and send it on email, that will be the easiest for me to process. Okay, now immersion technology definitions. I know that in the suggested changes, Nigel, you have included a different text for that. That's correct, right?
Correct.
Only the,
yes.
That's only the first part of that paragraph, right? Or is the rest the same? Is the rest identical?
No, it's all changed. All that is new.
All changed.
Yeah.
Okay, in that case, I was just about ready to read through this when I realized I had to open the call. All right, let's take a moment.
Should we read through it?
Review
If we read through it, then we could everyone could see if it's making sense to everyone.
So I can read it out loud, or everyone can read it for themselves, whatever is preference to everyone.
I love story time by Rolf.
Sorry?
Read it to us. It'd be great.
Yeah, read it out loud. Then everyone
Oh
is.
goodness!
Yeah.
All right, how many of you are ready to go to bed? Here we go. Bedtime story time.
Story time by Rolf.
All right. Liquid cooling within the data center is the process where heat is removed by a liquid rather than air. When a liquid is in direct contact with the electronics, this is liquid immersion cooling. There is a variety of liquid immersion technologies available to cool information technology equipment, ITE, within the data center. The common denominator for each immersion system with a dielectric liquid is used to completely immerse the heat generating. Hang on. The common denominator for each immersion system
Should be an is. Should we put an is? Yeah.
Is that a dielectric is used to completely immerse the heat generating electronic components. Okay, this dielectric liquid is thermally conductive with poor electrical conductivity, making it possible for use with electronic components. A dielectric liquid comes into direct contact with the electronic components to capture and transport the heat to a data center facility. Heat rejection.
Space after space with data center to space after data and before center. Thank you.
Yeah. The range of heat rejection methods varies by facility and require interfaces to connect to the cooling system. Terminology defined by ASHRAE assists with determining the classification of liquid cooling infrastructure. So, Datacom equipment cooling system, DEX, is the cooling system within the rack. Now, DEX does not extend outside the rack and contains a combination of dielectric fluids, heat exchangers, coils, of evaporators, in combination with self-drive and passive or pump circulation methods, valves, interconnection control electronics. Now, here is where I made the reference. So I just want to get into this here. I wanted to create a synonym between DEX and dielectric liquid when it comes to immersion technology.
But it can't be, because DEX does not equal dielectric fluid or dielectric liquid. DEX relates to the system and component system or subsystem that's within the rack.
Yeah, so in an open bath immersion system, it is the dielectric liquid.
Yeah, but we can't refer to it as a DEX then, because DEX is a data equipment cooling system. So it involves the combination of the any other ancillary equipment that will support the fluid movement, anything that's inside the rack. So that why it will include any pumps, heat exchangers, valves, etc., that are within the rack.
Yeah.
It can't just be referred to simply as a dielectric liquid.
All right. So as a matter of conscience, an aspirator system uses an integrated heat exchanger inside the dielectric liquid, which connects to the facility circuit, to the facility water system. So it becomes part of the facility water system. And the circulation of oil in our case doesn't require any system of any sort except for the tank that it's in. So we don't use any systems, any mechanical systems to make the liquid circulate. There's no circulation mechanism. The heat exchanging method is natural.
Yeah, but you do have a coil.
Where's DEX?
Do you have a coil at the top of your system that collects and vaporizes the gas?
No, because we use single phase. And that coil, and the heat exchanger in our case, is part of the facility infrastructure.
The heat exchanger is which side of the rack is the heat exchanger?
Inside, but it's connected directly onto the facility water circuit, so therefore it becomes part of that.
Okay, now that's your system, and I think we need to
exactly.
So we need to make sure that this applies to broader than just your system. So within the terminology that's applied to by DEX, we're talking about the system that encloses. So your enclosure with a dielectric fluid that is single phase, that's circulating with it. The parts that are all part of that inside that enclosure are your DEX. The fact that your heat exchanger is inside of it maintains it all part of the DEX. But it doesn't mean that DEX equals dielectric liquid. It is the combination of the system that relates to it.
So the tank is part of the tank itself is part of DEX.
The tank itself is part of DEX, correct?
Right. Okay. And what about? Let me take another example, just for me to explore the boundaries of this. If you're looking at a mechanical circulated system with external pumps to circulate the dielectric liquid, I would call that a technology cooling system. So if you have a CDU which circulates oil, is that TCS or is it still DEX?
So is the dielectric within is the dielectric directly pumped within the server chassis system?
Oh, let's take for example
interface and break between the dielectric pumped CDU and the tank.
I understand. Let's take a GRC solution, for example. You have one CDU that circulates oil across 4 tanks. And the oil is a dielectric liquid. It's being circulated through 4 separate tanks. The liquid leaves the tank, is transported by the CDU.
Yes.
And the CDU pumps it to a heat exchanger on the cooling tower.
So
I would call that a TCS.
CDU or heat exchanger. One CDU heat exchanger is supplying. There's no break between the CDU and the actual dielectric within the bath. Just to understand your example.
No, the dielectric liquid is there pumped away from the bath to a cooling tower and then back into the bath. And that CDU is maintaining the mechanical circulation within those baths.
That may be classified as a DEX. Right?
Because I would classify it as a TCS, as a technology cooling system, simply because it's a separate closed circuit.
Yeah.
You can compare it to cold plate. And this is where it's getting very complicated when you're trying to use these designations that are actually determined for air-based infrastructures.
These are referred to from liquid cooling infrastructures. It's based on that it's been based on. It's not based on air. These are talking about liquid cooling infrastructures.
Okay. So I believe that we've got quite a few crossovers with these sort of things. And if you look further down to the updated Redfish definitions as well, and also the methodology behind it, I think it's relevant to keep the option open that TCS may actually be part of the dielectric infrastructure. So if you look, for example, at GSC or liquid cooled solutions for that matter, it's the same thing. You actually circulated the dielectric liquid with a CDU.
Wouldn't the entire immersion system be part of the DEX and the TCS part of the immersion system? So it could be both?
Sorry, can you elaborate on that?
So the DEX, as it's described here, is the cooling system within the rack, but the entire cooling system is usually part of the entire immersion system anyway. So that would mean the DEX would be the entire immersion unit, and a CDU could be part of the unit, which is either within the DEX or without the DEX, depending on your solution. In the Espiritus case, it would be within the DEX, but in the GRC case, it might be outside of the DEX.
Yeah, but then the differentiation between technology cooling system and Datacom equipment cooling system doesn't really apply very well. Nigel, do you have any wisdom here?
I do. Sorry, I was on mute, so I apologize if I was quiet. Within the DEX definition, it is described currently that it's within the rack boundary, and where the sort of heat exchanger system is within the rack. With the example you provided of GRC, I'm not 100% across how their topology works. They have a shared CDU that would supply multiple racks. Now,
that is correct.
It's a question. So it's basically taken the central heat exchanger and extended it out to a larger footprint to support multiple racks. The question to then look at is to say, okay, from that CDU to the facility water system, is there does that have a break into it that goes through to another system, or is that directly through a facility water system, directly to a heat rejection tower?
That would so the CDU from a GSC solution would cool directly to the facility water circuit.
So that's similar to water cooling,
exactly.
Right? If you're doing cold plate, cold plate water cooling. So the definitions of I would say the TCS, right? That's where the CDU would go. You have a end of the row CDU that'll be able to provide a liquid to several different racks, right? And in this case, tanks. Right?
So I think we agree then, Jessica, that under that example with GRC, that's a TCS, right?
Yeah, that it fits more within the same boundaries as cold plate, right? We can go back to that. If you have a heat exchanger in the tank itself, right? Then I can compare that to the cold plate of saying I have an in-rack CDU.
Yeah, I agree with that. It's becoming a bit more clear. The only difficulty I've got now is sorry, Jessica, please continue.
No, continue. I just trying to draw parallels between the cold plate and the immersion, right?
Yeah, and I see those parallels exactly the same. And but the difficulty that arises with me is the fact that with if you look at the dielectric liquid, which is an essential part of the heat transfer mechanism, in the type of infrastructure that GSC applies, that same dielectric infrastructure gets outside the rack, so it goes out of the DEX boundary. So the dielectric liquid is not confined to the DEX.
Exactly, so, but you can do that in a cold plate solution too.
Not
right?
Yes,
the cooling
I do agree.
Liquid.
Yes. Yeah, you can.
You are correct. Yes, you are correct. But in that case, we will have to make a okay. In that case, we need to. All right, we need to assess whether this will impact the redfish definitions and the schematics that we've prepared for that. We'll get to that later on. So I agree. I think we do need to make a designation for dielectric liquid as an entity as well, simply because that's extremely relevant. And there's management and monitoring that needs to take place based on dielectric liquid itself, which may not be confined to DEX in that case. Would you guys agree?
I think we can For the current available terminology that ASHRAE utilizes, they don't have a definitive unit of measurement for a system that has a shared CDU in the same circuit to inside the rack, then back to it. They don't have it as defined because they define DEX as within the rack. And they have a clear delineation between the rack and then the TCS system. So I think we can certainly approach and speak with ASHRAE about what happens in this case with a hybrid system. But for this paper now, we can't refer to DEX as being the dielectric liquid. I think that we have, we need to change that. I think if you look at the introduction that I put in terms of definition, I've clearly highlighted I've clearly identified and highlighted the facts around the dielectric liquid. I've talked about its heat carrying capacity, and I've talked about its its thermal conductivity and its low electrical conductivity. So I think we've covered off the dielectric liquid there.
Hang on.
I was struggling with trying to remove these highlights earlier. I don't know what was going on with the formatting.
I don't know what's going on here either. None.
You can see it even got carried through to my comments.
There we go.
Nice, well done. Just one thing, within the third line above the datacom equipment cooling the DEX system, it's just got us an error on the to data center. It should be to that data center facility. I think it wants to put.
Yeah.
There you go.
Okay, I just gonna make sure that nothing gets completely lost for a final edit, but okay.
Yeah. So if we look at TCS, the definition of TCS clearly states that it's a dedicated cooling system by a central CDU to one or more liquid immersion enclosures.
Yeah, that's fine. Okay, so I'll continue reading here. Technology cooling system is the cooling system that is within the IT space, within liquid cooling, that is a dedicated loop system supported typically by a cooling distribution unit to one or more liquid immersion enclosures. Fluids used within the TCS vary and can be ethylene glycol or propylene glycol water mixes, pure treated water refrigerants, or dielectrics. Very good. Dielectric liquids in this case. A heat exchanger in combination with ancillary equipment. What does that mean?
Additional or other equipment. Supporting equipment.
Sorry, forgive me. If I don't understand the words, then then a lot of other foreign people will not understand either.
we know that about you, Rolf. So that's not the first time we've had this. That's great. No problem at all with that.
Now I feel very dumbed down. Okay. Where were we? Supporting equipment is used to, so a heat exchanger in combination with supporting equipment is used to transfer the heat between the TCS and the DEX to the facility water system. Hang on. A heat exchanger in combination with supporting equipment is used to transfer the heat between the TCS and DEX to the facility water system. Why is there supporting equipment?
I think TCS/DECS.
Yeah,
right?
It's one or the other, never both.
Those two.
Yeah, that's good.
No, it's a combination of them, right?
Yes, correct.
Okay, good. But why is there supporting equipment?
Well, you need to have plumbing, piping, supporting structures, some form of pump. You need electrical circuits and other things that will go with it.
But a heat exchanger itself, I mean, that supporting equipment is already part of the TCS, right?
Part of the CDU. Yeah, the CDU is part of the TCS, right?
Yeah, so that means the supporting equipment is already covered for in the definition, right?
Should we flip the order there and put DEX/TCS to kind of follow the heat flow, kind of as what it's shown, you know, the DEX to TCS? Does that make better sense?
Done.
Yeah.
Thanks, John.
I'm struggling with the supporting equipment here because it raises the question, what is the supporting equipment? So do I need more than the heat exchanger that is coupled to the TCS and the facility water circuit?
It's purely meant to define the fact that you'll have some form of plumbing, perhaps a pump system included within it.
Yeah, but that's defined by the TCS system, by the technology. If the technology cooling system requires a pump, it's defined by the technology cooling system. Sure.
So if everyone agrees, we can remove those 3 or 4 words out and adjust that slightly and take it to say a heat exchanger is used to transfer the heat between the DEX and TCS to the facility water system. I'm okay with that. John, any concerns?
No, I mean, the heat exchanger is what's doing the thermal heat transfer, so we're really not talking about the conveyance of fluids here, I guess. So I think I'm okay. It's because we're talking about the transfer of heat. So I think it's okay to just use heat exchanger, maybe drop some of the ancillary items off or extra equipment, however we wanted to word that, right?
Yeah. Cool.
Yeah, that's fine.
Right. Okay, now facility water system is the facility cooling system. Is a facility cooling system and contains the heat rejection plant. It needs to. I'm just going to make this perhaps a hypercorrection, but I don't care. Facility.
That's fine.
And contains the heat rejection plant equipment and could include and may include a cooling tower pumps. Cool. Everyone happy with this? Sorry, I didn't read it out loud. Facility water system is the facility cooling system and contains the heat rejection plant equipment and may include 1 or more cooling towers, pumps, chiller units, direct expansion, or dry coolers to disperse the heat to atmosphere. I do have a problem with that statement. Because now we're defining that a facility water circuit is limited to what we just described.
What is that?
Well,
in what way?
Infrastructure. What about reuse?
Yeah, what
then
about reuse?
Then you don't disperse to the heat to atmosphere, but to.
Well, we say it may. It's limiting though. It says it may include. It doesn't say that it has to include, right? So it may include 1 or more. But I guess the fact that you have may in there kind of gives us an out that it could be other things.
Yeah. Why not just heat rejection plant equipment and forget about the rest? If you want to know more about that, read another white paper about data center cooling or facility water circuits or cooling infrastructures. Or yeah, exactly. So there is plenty, but is it up to us to define that circuit, that system here, or just refer to it as the water facility water system?
What it does, it does give assistance in the understanding of what the facility water system is referring to. So by mentioning the fact that it's got cooling towers, pumps, chilling, etc., it puts an aggregated set of components of plant material that's typically used within it. And I think those that are in the space around data centers will be able to understand that quite clearly.
What about this? I can change it back, huh? So
Within,
would that work? Then at least we're taking a bit of we're pushing a little bit to think slightly differently.
I think in this case you want EG, not IE. I think EG is meant to be more exemplary, not limited to. So I just be a little bit of a weenie there, right? Yeah.
Is that with dots in between?
Yeah,
Like
yeah, correct. Yeah.
All right, cool. But I was obviously referring to the content.
Yep.
Nigel?
Yeah.
What is a heat grid, though? I'm not quite sure I understand what we're trying to convey as a heat grid.
Oh, yeah, you're American.
Yeah, I'm sorry, I apologize.
So then you need to start defining what a heat grid is.
Cool. Do we really, Nigel, or can we just leave it as is? I mean, this is a bit of a European thing, isn't it? It's a distribution net for heat across cities.
Oh, okay. District heating plant kind of thing then. Okay, gotcha.
Yeah.
Okay. Gotcha.
District heating. Yeah.
I think more novices will understand with that language than just.
Yeah, fair enough.
Okay. Yeah.
You're happy with this, Nigel?
Yeah, that's fine.
Or you prefer
I just want to point. Part of what I wanted to point out was that it's maybe not only water, right? ASHRAE is focusing on water, and just want to make sure that we put that into that it could be the other liquids, right? That we extending the use of it here.
Yeah, but typically within a facility within the FWS circuit, it's a larger circuit. You may find the use of a refrigerant or alternative fluids within the TCS. You may not find that within the FWS.
Yes. I just don't want to not have the option, right? Of saying that it has to be water.
But
I know that
yeah.
I know that you mainly find water there, but I don't want to limit it to that.
So what if I just put this note underneath?
So what do we say? What are we as OCP saying that it's going to be instead of water?
It doesn't matter what it is, but it's just not limited to water. It can be. There's a lot of stuff happening currently with nanofluids and optimized liquids that are further optimized for heat rejection in closed circuits that can run across a facility that will allow you to reject heat at much higher densities compared to water. So you don't want to limit that. Correct, Jessica? You agree with that statement?
I'm fine with that. It's not limited to water, but can also, be other cooling liquids or something along that line. Yep.
I think, Nigel, to your point, water is going to be a difficult fluid to displace on this length scale of heat transport, but I think there are folks looking at other fluids. So I think it's good that we not put ourselves in a box there.
All right, cool. I feel that it will help us further along in this document as well if we do define dielectric liquid here as a domain comparable to DEX or TCS, but a domain that may overlap between DEX and TCS. Simply because there's metrics that do apply to just the dielectric liquid as opposed to the DEX or TCS.
I see dielectric liquid as a working fluid. It's not a domain.
Yeah, but it's a relevant protection mechanism for the IT, which is the whole point. That will have that will require certain measurements and certain metrics to be monitored. So to define, let's say, sensors that are relevant to, so if a dielectric liquid, let's take the GSE solution for example, we will require measurements of input and output temperature of the CDU in that case, but that relates to the dielectric liquid's inflow and outflow location. Within Asperitas, that is within the DEX domain, but with a GSE solution, that is in the TCS domain. So I can't determine the location based on DEX or TCS. I have to determine the location based on the dielectric fluid.
You can determine it based upon the CDU, right? It doesn't have to be based upon the dielectric fluid as I see it. I think it's more in combination to the CDU.
Yeah, and that's where I'm afraid that we're going to start entering into a limiting domain.
Well, it's not only limiting because of that, but in the case that you have a single CDU, for instance, with the GRC case, you will have multiple baths, and you would want to know the temperature in those baths, and that would be the dielectric temperature, and not the CDU temperature.
Yeah, so it's at the inflow of the bath, so you can determine it on the DEX level. That's what you're saying?
Yeah.
But I also want to know, I agree with that, but I also want to know it at the CDU level to make sure that I,
Absolutely.
you know, how much power that I actually cool through the CDU, and if I, you know, have any issues with that, right?
Okay, so keep that in mind. So let's leave this for now. So let's not define dielectric liquid as a domain then. That's okay. If you want to change that later on, we'll keep that for a revision. Let's just quickly walk through this because then we can get to the actual subject matter that relates to this a bit sooner.
Do you want to go through the rest of the changes, or?
Yes. So let's do that indeed. We will not have time to cover the IT gear specs today. The TCS is usually designed for 100 kilowatts or more, whereas an integrated heat exchanging device is usually designed for 10 to 100 kilowatt cooling capacity, usually. And you're saying this statement is incorrect, suggest removal.
Correct.
I did confuse here TCS with a CDU that facilitates multiple racks.
Sure, but even there's CDUs on the market that can support up to 305 kilowatts at the moment. So if we put a limiting figure into it.
No, it's 100 kilowatts or more. Below 100 kilowatts, you're not gonna. So if you're doing 50 kilowatts, you're not likely to use a CDU that facilitates multiple racks.
Could we see in
50 kilowatts?
Could we see in context of the document? If we just, I think it's
so the TCS. Yeah. So this goes with open. So this basically relates to CDU approaches. CDU that is away from the rack, that's not an in-rack CDU, but so more towards, let's say, the GSE solution, or a cold plate solution that facilitates multiple racks in that case.
And this is where it started becoming a little bit unclear to me when reading this, because most of it, when I see TCS, I want to put in CDU instead.
Yes, and I agree. But since we now also define CDU as an in-rack CDU possibility, because now suddenly Asperitas is also using a CDU, which means that we can't use the term CDU in that context anymore, can we?
I think we can. I mean, the CDU will always be hooked up to, it will be a heat exchanger and it will be hooked up to facility cooling, right?
Yeah, but TCS is in between the facility cooling and the DACs, right?
Yes.
So therefore,
TCS is between
a
the
TCS,
decks and the FDACs. Yeah.
therefore a DCS will usually not support one rack, because otherwise you would have an in-rack TCS.
Right.
Or
It could depend on the system that you're deploying.
yeah, but it wouldn't be logical to have a TCS that facilitates only one rack. So you would assume that a TCS will facilitate multiple racks. Otherwise, the economy, the scale of the, otherwise you don't benefit from an economy of scale with a TCS.
So we're saying that
it's
TCS
designed for more. That doesn't mean you have to hook it up to more.
It's just the only reason why this paragraph is in there is to determine that the TCS is usually implemented for larger for larger densities, for larger amounts
with a
of
TCS,
compute.
with a TCS unit, you may just be connecting it to a cold plate, and each of those cold plates may only be having like 20 kilowatts of heat.
Yeah.
So you might be connecting 3 racks to them, which means your load in your TCS CDU is only 60 kilowatts. And the issue I have with this line is that we're saying that it's delineated by 100 kilowatt, right? So, you know, I think that a TCS doesn't necessarily start at just 100 kilowatts. It could be lower.
Okay. I think the amount of questions that are being raised with the paragraph is already too uncomfortable, so I think it should be deleted.
Okay, let's go to the next one.
Yeah, agreed?
Yep, no problem.
Anyone? Good. Sonny, you proposed mean time between failure.
Yes.
The MTBF and MTTR to be taken into consideration for immersion tank.
Yes.
It's a great idea, but I think it's to apply that to an immersion tank or a DEX. Can I assume DEX here instead of immersion tank?
Here I'm asking about the immersion tank.
The whole tank.
Yes, the whole tank.
So the question that raises with me, I think it's a good idea if there is something that if there are any active parts in the DAX. Would you agree?
Yes, I agree.
So a passive DAX, so a DAX that does not contain any moving parts, like for example the isotope solution and asparagus in this case, there is no moving parts. Would that mean that an MTBF figure would be useless? Or would it just be very, very high or very low? High, sorry.
As because we don't have a associate experiment, so we would like to listen to your suggestions.
All right. So does anyone?
Yeah, Rolf, I think that for the tank there will be also some electric parts like the tank management system. It may be a motherboard or a PLC module. So within that the tank is not only the mechanical parts, but also some electrical parts.
Well, that could be, not necessarily though. So that's not necessarily the case. I agree with you when you're talking about full integration of technology.
Well, I think we all agree that MTBF and MTTR are important things to understand. But within the context of this paper, right, I'm struggling to understand what we would say about it within the context of this particular document, right? It might even be a subject onto itself, right? I don't know. It could get very expansive very quickly.
Yeah.
I
Yes.
think this it starts raising a lot of questions in my head, which I think are very interesting. I do not think we will have time to discuss this properly for the current submission, but I'm very keen on covering this towards the next release of the paper to see if there is merit to take that in. Would anyone else like to confirm or decline that suggestion, perhaps?
Yeah, I just think it's a slippery path to go down. And explore for next paper. I agree with that.
Yeah, I'm supportive. Yes. I'm supportive of that.
Yeah, I think that should be good.
But I think it's important. I think for that it's important, but definitely agree. Explore for next paper.
Okay. Nigel, any liquid system may only be placed in a well-ventilated room. This is not required for enclosed chassis systems that utilize single-phase immersion. Suggested change. Any open bath liquid immersion system may only be placed in a well-ventilated room. Does anyone want to comment? I tend to agree. Does anyone object to this change?
No, I don't.
No, I agree with it.
Okay.
Wait a second. This is Daniele from Submer. What about deploying these systems in containerized solution, for example?
It still needs to be ventilated. If you have to access it as a human, you have a large body of chemicals inside a small closed environment. It has to be a ventilated room.
Right. But in that case, the opening for the human to access it counts as ventilation.
Well, if there's ever going to be a human presence in the room, you need to have it ventilated. It needs to be a ventilated room, and just opening the door is not a ventilated room.
Yep.
All right, I understand.
Yeah, I mean, this gets to be a tricky subject though, because you're talking about your Pell limits and ventilation rates depending on the vapor pressures of the fluid, right? So I guess we just let it be a thing of consideration, but well ventilated is kind of ambiguous, right? But at the end of the day, if you've got vapor pressures of the chemical that are at risk to human health, then you've got to make sure that you understand the MSDS and you ventilate to comply with the exposure limits, right?
This actually comes directly from the chemical safety sheet, from any chemical liquid. So working with chemicals, the statement is commonly a well-ventilated room.
Yeah, but that's an ambiguous as heck statement, right?
I agree. But it's up to. I think there is a responsibility for the provider of whatever open bath technology is going to be deployed to determine or to advise on how ventilated it should be.
The chemical providers provide the instruction. They mean what they say. They say in the same document what healthy vapor pressures are, and that it should be in a well-ventilated room, which suggests to me that they mean it's well-ventilated if the vapor pressures remain under normal health and safety numbers. Sorry.
Okay, for the record, people, we have reached the end time of this meeting. I will keep on going with whoever wants to remain present, but be aware that the call might be might be ended abruptly if someone else is starting another session.
Could we scroll? That's great, thanks. Could we just scroll to the top of page 11?
We are there. So the page numbers have changed.
Perfect. Okay, cool. I'm with you. That's great. Thank you.
Yeah.
Another question.
Is there a suggestion to change this?
No, it's another. We've got data centers, one word, and just my consistency, internal consistency voices.
Yeah.
Or alarms.
No,
Sorry about that.
That's fine. That's fine. But about the well-ventilated room, is there anything we want to add to that then? That it's well ventilated.
That's fine.
To refer to MSDS packs.
Guidance. I would like to say
keep it
see the MSDS. No, I would like to see. I would like us. We're going to give guidance. Let's be careful that we don't end up somehow owning something. That's why I personally would say let's hey, give them alerts. Go look at the MSDS. Do what it says, right? And whatever well ventilated means for that particular substance, right? So I just think we need to point folks to the MSDS and say, okay, we've done our job here, right? And not take on any responsibility for ambiguous guidance, right?
No disagreement with you on that one, John.
Yeah, if there is something that we can add to it to guide people in the right place, I'm all for it. So what about this edition as specified in related MSDS documentation?
Provided by the dielectric provider.
Yeah.
Does this also pertain for closed bath two-phase solutions in case of overpressure ventilation?
Yes, because those closed baths are still open baths.
Oh, okay, that figures. Thank you.
So the definition also covers two-phase solutions.
Great.
Okay, the word FWS appears to have been recently inserted. Okay, we'll run through that later on tonight, Nigel. Is that okay?
Yeah, that's fine.
We'll take care of that consistency. All right, section 5.2, page 9, large low resolution graphic. I think you will be referring to this one.
It looks better now. Okay. Oh, good. That's fine. It's coming through.
Yeah, you may have been working. Yeah, I was editing it yesterday, so you may have been doing that while I was fooling around with some images. Okay.
No problem.
All right, kilonewton per square meter, bare solution filled with liquid, including clarification required to confirm if this FWS or TCS. Good point.
This goes in, yeah.
That's the.
I think I put the name and then the page number. Yeah.
I'll change it like this just to refer to liquid interfaces, then whatever it might be.
Okay.
Happy with that?
Yes.
Okay. FWS and TCS, we'll cover that later. Add references. ASHRAE, that's in the bottom, right? In the
right at the bottom
of the document.
You could just copy those and just put those in. That'll be fine. I formatted them appropriately. We should put references in alphabetical order as well.
We'll make that nice and neat later on. And you're talking again about an image, this one?
Yeah, great, perfect. Okay, good. I couldn't see them on my version.
Right, okay.
That's fine.
Good. Okay, there are some...
Is that image in the public domain? Because I've seen it before. Is it copyright?
It's the only one. It's the only one that is.
Okay, cool.
It's the only one that is. Yeah, it's also on the Wikipedia, I think. And it does contain a reference to the Atlas Steel technical note number 7, galvanic corrosion. This is the only one that's widely used on the internet. So I did check. I will recheck that. I'll make a note of that.
Yeah, I've seen it many times. I just wanted to make sure that it was in the public domain and not somehow copyrighted.
I'll double check that if I can get some confirmation on that. So finally, the biggest change, I think all the changes that are marked yellow are in line with what I'm going to go through tonight with Nigel as well for consistency. That all relates to the updates on ASHRAE terminology, TCS, FWS, that sort of thing. The content addition that I made based on the last call was provided by Marijn. He's in the call as well. That is related to the redfish definition. So last time we discussed the redfish definition, there was quite a bit of confusion around terminology used here as well. And also about the way that the script was set up. So Marijn, why don't you quickly walk us through this and share the insights of how you set it up now?
Right. So the idea with the redfish definition is that it will provide a standardized protocol to communicate with. The image you see now on the screen shows the obligatory items, and that is cut up into 3 parts. At the top, you see the full immersion solution, and this might jiggle around a bit with the DEX and FWS and CDU discussion that was going on a bit earlier. But this is the idea that was at the status of yesterday. So, and what you see here is all the values that are required for a system, and the colors relate to the level of requirement. So anything green is required anyway for each system. The red ones are for a high safety system, and the blue ones are for a thermal optimized system. So you have for the entire system, for one immersion solution, it's required to have a thermal status. And if you want to have a high safety system, it's required to have an alarm status. And this triggers down a bit. So if you go into the FWS, so the facility water system, you have an array. If there's any block, what do you call that in English? Block parenthesis around it, it means it's an array. So there could be multiple. So any input temperature and any output temperature for the facility water should be noted if you have a thermally optimized system. For safety, you should have a pressure measurement available for each facility water system. That's the idea of how it's written down. These are the required items for each item. You can add more. It's allowed and possibly even suggested to add more. We'll come to that in a bit. So
I'm thinking for the TCS system that may be applicable. I'm thinking it's going to be challenging for the FWS system. Now, John Bean, I don't know if you're still on the call, but you could perhaps clarify, because you're probably more experienced in the FWS domain than I am.
Hang on. Before you go in there, Nigel, let me just explain it, that these values are provided by the immersion technology provider. So in our case, that is the connection point on our technology that interfaces with the facility water circuit. So it's not part of the facility itself to monitor, it's part of the total immersion solution already.
But it might also in some cases extend beyond the cooling provider's domain. For example, if they work with an alternative CDU provider, they will need to, it may not be possible. Now, when you put within your system, you have one circuit, as you said, you connect directly to a FWS. Within your example, that may be possible, but it may not be able to blanket to all domains, is what I'm just thinking about. I'm trying to think broader than just our collective
Well,
topologies.
at some point you're getting coolant water from the facility, right? Into your immersion solution to get the heat out, and that is what is being referred to here.
Do we have a legend for the color codes anywhere? I mean, you
Yeah,
spoke
yeah,
to.
it's actually
there.
it's in the
Okay,
next
there it is.
table. I'll move that to.
That's better. Yeah, it was the other way around some time ago. So you're going to get some coolant water from the facility at some point into your immersion solution, or is that already too narrow of an assumption?
It may be, yeah, it may be coming from.
Yeah.
It may be a boundary between the FWS and the immersion cooling system.
So it's the FWS interface that we're talking about here of the total immersion solution. So the boundary box here of immersion solution is around all these things. So at some point, any immersion solution must have an interface to a facility infrastructure. That is something that we require based on this document already. And that interface is where you need to be able to measure the output temperature or the input temperature if you want to have a thermal optimized system. Only then. So it's not part of the minimum requirement. It's only required for the thermal optimized classification. And for the high safety requirements, if you want to comply with that, you need to have the pressure rating as well as part of the alarm infrastructure. And so you need to have a pressure sensor on that water input to your technology. That's in line with the specs, the requirements specification. Is that is it clear? Is it clear, Nigel?
It's clear. Yes, it's clear. I'm just trying to think of areas where you may not be able to have that access to information, or you may have a problem with the interface between the CDU and the immersion systems.
In that case, you will have a problem qualifying for this document, in line with this document, because this is what we all already approved in sense of these are the minimum requirements, and this is how that is displayed in a graphical way. This is only
this is built upon those minimum requirements, and this is only the definition and illustration of how it is placed into an actual API protocol and where that all fits. It might make it clear enough that the definition seems harsher, but
there's just one modification that we're going to need to make in this image, and that is the block that is now called dielectric liquid. We'll need to change back to DEX, and we need to make a drawing of a CDU inside the immersion unit.
But you can also have a CDU outside of the immersion unit, so that's going to be a bit of a puzzle.
So it's optional. No, but it's optional. So if it's there, then that's where you need to make the measurement.
Yeah. Okay.
That's
Could
the
you
point.
scroll up again?
Yeah. Go ahead.
Yeah. So going forward, that you have some kind of FWS interface that can go to a TCS. That is an optional bit. If not, it will go straight into the dielectric liquid, for instance, in the Asperitas solution. If you have a TCS, it would show a status. If it's thermally optimized, you would be able to set a set point and see what capacity it is on. And if you have a high SIST system, you would be able to influence the pump actions, but only if you have administrative rights.
Yeah, but a majority of systems won't, that I'm aware of currently, majority of them utilize a TCS. Yeah. So what you're demonstrating here is not the traditional standard solution for transporting directly from FWS to the CDU, or directly into the, from this FWS directly into the immersion tank, because of your high volume water flow rates and pressures that are involved with that.
Yeah, and that because of that, you often have a CDU in the middle, which is shown here.
Which would be a TCS.
Which would be a CCS, yeah.
Exactly.
So it
But it
says
says
there.
TCS is optional here.
I'll make sure to update this image to reflect that.
Well,
To reflect that that's an optional either here or there, or sometimes both. So you can imagine having an intermittent. If you have a heat exchanger, if you hook up an aspiratus box to a CDU installation with a closed circuit with a very highly efficient liquid to facilitate a lot better heat transfer, that's all great. Then we have a TCS as well. With
so
the CDU.
then within GRC's system, because you referred to GRC system earlier, then they would have an FWS input directly to their CDU, which is a shared CDU then connected to their immersion unit.
Okay. And without a CDU inside, without a CDU inside, that's correct.
Yeah, and that would give you multiple dielectric liquid units within that immersion system. The immersion system being the one sharing the CDU.
A question there too. Isn't the facility side of the CDU, shouldn't that go into the facility water supply or system?
It does.
It does.
So the lines are open-ended to show that they go into the facility water side.
Okay, but be part of the, here we're saying TCS. So maybe I'm just confused where we have the TCS versus the FWS.
TCS is the box.
Yes. And I'm saying that isn't the box supposed to go in the middle of the CDU? Is my question.
Well, it depends
and
on whether you want to make this. It depends on whether the interfaces of the CDU are facility water system, or the CDU itself becomes part of the facility water system.
Yeah.
I think, to be honest, I think we are getting too technical on this. I think the intention that we wanted to achieve is clear and it's covered.
But the definitions between TCS, FWS, and DEX, they need to be figured out completely clearly before you can really do this, I think.
Yes.
Exactly.
Yes.
Exactly.
I agree.
I agree too.
So what do you want to say with that? That we need to revisit this whole thing and take it out and submit it without all this?
Well,
or because I think what is in there now is perfectly in line with everything that was already defined, and I think this does the job. What we're talking about is just defining whether something is, whether it's an interface or graphically the CDU becomes part of X or Y. I think when we're talking about measurements.
Well, measurement-wise, this fits completely. Left, right, or center. No matter how you draw your boxes, this is how the values interact. What way you draw your boxes around it or not. I think we can all agree on that.
I'm happy to rearrange the boxes to let it go through half the CDU and add another CDU to the top of the immersion unit and let it penetrate there. Is that something that everyone would be comfortable with?
Well, I'm trying to understand how much harm may come if this evolves over time. Are we painting the foundation that gets us in trouble? Or do we have a foundation that we can evolve without, retracting things, It's kind of what I'm trying to sort out. I don't know how problematic this is as a foundation as it is. I'm not clear.
I've looked at a few other examples for redfish implementations, for instance, defined for crack units and stuff. And they basically use the same system. So they define water input pipes as FWS input as well. And if someone were to connect that to a CDU, that's basically a problem of the person building the overall system of monitoring, but nothing much more. So this is how it's usually being done. And if you connect it up to something different, so then your FWS connection of your immersion solution becomes, in the bigger picture, becomes your CDU connection if you connect that up to a different CDU again. But this system does allow for nesting and moving that around. And if you're starting to move and nest around like that, it's going to be confusing left, right, or center anyway.
Yeah,
well,
I
just
am kind of surprised that there's no monitoring for the oh, there is, I see it. It's in the kind of hard to see the DLQL level. Okay, so we do have the dielectric level. Okay.
The dielectric level. So I'll run through the rest of the values shown now while Rolf is rearranging some stuff. So the FWS I think is pretty clear. CDU, that's just whether it's, so TCS status is whether it's on or off. Set point, it's whatever the set point is at. It could be percentage, could be temperature value, depending on the type of CDU and type of control you have there. It could even be an RPM set point. Capacity is percentage based. If you have multiple circuits, it can be multiple percentages. And pump actions may control turning on, off, setting auto mode for the TCS. And from that, the TCS couples your FWS system into your dielectric liquid system. And there you have your input and your output of your dielectric system, which in an open bath will be like the bottom of the bath, and the top of the bath in a closed system, it will be the same thing. And if you have a dielectric liquid with high safety, it also shows in the middle within the liquid, you would have a quality and a dielectric liquid level sensor for high safety. And for the entire IT confinement, you would have, which is all within dielectric liquid as per immersion definition, you would have the total power input in kilowatts. And for high safety systems, you would be able to influence the power input into it. So you would be able to shut off the power with admin rights. You would be able to shut off the power input into the dielectric liquid. Any questions on the values itself, disregarding where they're exactly placed, seeing as that's being moved around as we speak?
not really moved around, to be honest, but all right.
Well, this does paint a bit more clear. No questions? So this is all clear? Okay.
Is the image that I've just sketched here on the screen, is that explanatory? Does that cover everyone's thoughts?
It does for me.
So the biggest change is the location of the boundaries. boundary boxes. Okay, I'll make sure to work this image into the documents and replace the one that's currently there.
The DEX boundary box should probably cross completely over the INRAC CDU, but it will be messy. No,
I don't agree, because that interface is on
the interface of the INRAC.
It's the same discussion as the TCS
Agreed.
CDU.
Yeah, great. Yeah, works for me.
All right, then I'll make sure to work that in. Okay, so content-wise, then we get to the actual scripts, which is in the document here. The script language. This is the designation of everything. This is in line with. It's the same thing as in the image. Except for the addition of some optional elements which might become mandatory at some point, but for now there are recommended settings that we have defined. Since you want to be able to identify systems. And this contains some more elaboration on what it means and what they actually do.
Okay. I need to drop out of the call shortly too.
Yeah, go ahead. Okay, no more questions on the redfish. Is there anyone who disagrees with either the image that's going to be used or the script? Okay, then I consider this fine. I'll update that image tonight as well. For the rest, I have made a modification which I wanted to show or discuss the non-IT power overhead of a solution to make that consistent with all the other metrics, to make it relate to something. In this case, as well to the square meters.
So non-IT power overhead is related to within the rack enclosure, what power overhead is using.
For management system monitoring or lighting, everything else we're now relating to square meters.
Yeah, that's fine. So basically, it's taking the previous metric that's just above it and just giving it an area.
Yeah. So the non-IT power per kilowatt, so if that relates to the amount of kilowatts, not so much to the square meters.
Yeah, but then you've included a version with density. Okay.
I've rephrased classification to hazard statements to be in line with the industry standard for MSDS documentation. And I've taken the liberty to just write out this specific warning that applies to, as far as I know, all hydrocarbons below a certain viscosity. And I think there's an outstanding question with 3M, which they still need to get back on, whether this also applies to fluorocarbons. But I believe it does, but I don't know for sure. But that's not relevant for this document. It just states that it needs to be classified. Anyone object to the rephrase of hazard statement and explaining the H304.
I understand H304 is summarized at that, and anyone who wants to look at the H304 certification should be in a position to go and do so. So I think
No
it's
objection.
showing. I think it's showing. It's showing. I think to our potential customers and to the market that you should be concerned about the dielectric fluid that you're taking in, and that it needs to set some certain safety parameters. I think that's fine.
Yeah. So no objections? Good. Then the rest is back at FWS.
Do we have
FWS.
I've just seen a message from Michael Schill. Says there's a security call on this line as well. We need to get discussion on the mailing list.
All right, cool.
Okay.
We just finished the whole document, so let's thanks all, and till next week. I'll finish this off tonight, and I hope to see you all again next week.
Thanks, Rolf.
Thanks.